Now that you have completed the Stella, I'm gonna go ahead and attach the upper housing onto it, make it a little bit cleaner. Now we're gonna begin actually taking some measurements with it. So, quick overview, the Stella reads 12 different wavelengths in the visual light and near infrared spectrum. These 6 values on the left correspond to violet, blue, green, yellow, orange, and red, respectively. And the 6 values on the right refer to the wavelengths that the number there lists in nanometers. Some other useful things it reads are the surface and air temperature in Celsius. When you turn on the Stella, it will default to the blue center mode of the Stella. When on, the blue mode will just take data points continuously and automatically save them into a data Excel sheet on the SD card in the back. You can go ahead and start and stop the mode by either pressing the button here or by pressing the touch screen on the icon there. The two other modes are the yellow mode, which when activated, each press of this will just take a single measurement and then stop. And then there's the green mode, where upon pressing, you'll get a unique screen where you have to wait a few seconds. Then it will take 20 measurements in quick succession and automatically find the average and standard deviation of that set. On the data sheet that the Stella will automatically make, the green mode will appear as a single data point showing all of its average values. The green mode will also create a unique Excel sheet every time you take a measurement that will show all 20 values in the set it just made. So first thing we're going to do with the Stella is make sure that our spectrometers are giving us reasonable results. So to test the visual light sensor, here we have 3 different colored sheets with very obvious visual color differences. And to make sure that our measurements are even cleaner, we have a light box set up here. What this is going to do is create a more neutral lighting environment. And we also have, these are 6500 Kelvin LED light bulbs. These are going to be much closer to the light that natural sunlight produces, especially compared to iridescent classroom lighting. It's important to note that, especially when testing indoors, the LED lighting indoors is not going to be uniform across all wavelengths. There's going to be certain wavelengths, especially orange and red with LED light, that are going to be disproportionately higher, and you need to consider this when taking measurements. So here we just have the Stella pointed at the colored cards inside of our light box, and looking at the left row values on the Stella, you can see that the green value is notably higher than any of the other wavelengths being detected. If we change the color that's being looked at here, you should notice that the light then changes and is now much more orange focused than it was before. And if we change it once more, you should see that the values begin to shift more towards the violet. Another interesting thing to note here is that the Stella device is a bit less reliable with darker colors, just because there's less light being reflected into the sensor, and so the margin of error is higher. So a darker color like this, the purple isn't quite as pronounced as it was with the orange and the green.
Now we can go into detail about what the values mean and what to do with them. The Stella provides raw irradiance values for the different wavelengths in microwatts per square centimeter. The sensor has an instance of 40 degrees and reads everything within the cone, formed as a product of distance to the target and the instance angle. Based on how far you are from the target, the area that you are measuring will change in size. To calculate radiance, we multiply the irradiance by the distance from the target squared and divide it by the area measured. To calculate reflectance, you must measure a highly reflective medium, such as a sheet of white paper or white photography card, in the same environment and calculate its radiance. Dividing the radiance of the target by the radiance of the medium gives you reflectance. You can average the irradiance values before you calculate radiance, or you can wait until you have reflectance values for each wavelength before averaging. That depends solely on what you are trying to measure and analyze.
So now we're going to be showing an example of taking a practical measurement with the Stella. We're going to be showing off a method called the calibration sandwich, where we're going to take a measurement with a reference material before and after taking a measurement with the target plant. This will be to increase the reliability and usability of the data that we get. It's also important to note that the testing conditions that we're in, for example, right now we're in a shaded area with some decent cloud coverage overhead, but we've got pretty even lighting. Depending on how much the lighting is changing where you're testing, that'll influence how quickly you want to take the reference and data materials, since you want to minimize any changing light conditions. So, to begin, I'm going to be set on the blue mode, and I'm going to take data measurements in bursts of 5 or 6 seconds or so. Then once we're analyzing the data, we're going to take averages of these points to get a better data number. Another thing that's important to consider is the angle that you're holding the Stella at. If you're measuring like just a big field, you're going to want to get as close to flat above it as you reasonably can. Since we're going to be measuring a flower here, we're going to try and be tangential to the surface of the flower to get a good measurement of that. We're going to gauge the distance to be as close to 10 centimeters as you can reasonably get it. Once we're there, we're going to slide the reference material right in front, start taking a measurement, hold it here for a few seconds, stop, switch, give it a second or two to readjust itself, and then take the next measurement, give it a few seconds there, stop, replace reference, go back again, and then once you're done, it's important to note what batch numbers the Stella was running off of. For example, here, that was batch 1 and 3 were reference materials, and 2 was the actual data itself.
Reflectance is useful to know since the reflectance of a healthy plant will usually follow a consistent pattern such as this. Reflectance is the ratio of reflected light to incident light, or basically how much light is reflected off a surface over how much total light hits the surface. A perfect reference material would reflect 100% of the light that hits it. Since that is unreasonable in most circumstances, you should just get as high as possible. If you know how much light your reference reflects, such as 90%, you can multiply your reference's radiance value by a scalar to approximate 100%.